Today we're going to be learning about logarithms. So the first thing when you think about a logarithm is what is a logarithm? So a logarithm is basically the inverse of an exponent function. So if you have, let's say, a to the power x, if you take log base a, and as you can see, base is this value right here, log base a of a to the power x, you're going to get x. And that's what it's entirely based upon. It's basically like undoing the exponent. And to get ourselves more familiar with logarithms, what we want to do is look at this diagram. So how you would pronounce this is you would say log base a of b is equal to n. So n is the value of the logarithm, and b is the argument of the logarithm, and a is the base. It's the tiny thing at the bottom that I have circled. And you can put this into exponent form basically by doing it in reverse order as b equal to a to the power n, where b is the value of the exponent, a is the base, and n is the power. And so what you're seeing here is that if you do log base, whatever base you out of the exponent, of the value of the exponent, you're going to be able to find the exponent. And so this is really useful for finding the exponent of numbers, or the exponent of different numbers with different bases. So now we have to learn about the properties of logarithms. So like how we can manipulate these logarithms with certain rules. So the first and most important rule for logarithms is that if you take log base a of a to the power x, it's always going to be equal to x. And so if you put this into words, it would mean that like logarithms and exponents, if they have the same base, that means that they're inverses. The next important rule is the multiplication property. And this property basically means if you have two values multiplied inside one log, you can split it into addition. So if you have like log base a m times n, you can say it's equal to log base a m plus log base a n. This should not be confused with a variety of misconcepts, like a lot of people like to say that log a of m plus n is equal to log a of m times log a of n, and this is wrong, and it's really easy to make a mistake between these two, and so you should always try and thoroughly remember the first one and not the second one. The next important rule is the division rule. And so if you have log m divided by n with base a, this is going to be equal to log base a m minus log base a n. But like the previous example, like the multiplication rule, it's really easy to switch these two, and you always want to memorize the top one. The bottom one is completely wrong. So for all these rules, something important is that for logarithms, you can't use the distributive or associative property with logarithms. Like if you you can't use them like you would with regular arithmetic. There's other rules for logarithms. So the next important rule is the exponent rule. So if you have log base a m to the power n, the n has to be inside of the logarithm, by the way. So there has to be a parentheses like this to indicate it. This should be equal to n times log m with base a. And so the way this formula came about is like if you have m to the power n, what does that mean? You have log base a of m times m times m times m times m n times, basically, right? You have m multiplied with itself n times. So then this would basically be equal to, when you use the multiplication rule here, you can split this into log base a m plus log base a m plus log base a m n times. And if this doesn't make sense, well, you just use the multiplication rule a lot of times here, and we split it into n different terms. So there's like n of these. So there's n. of these. And so they're all the same term, so when you add them, it should just be n times log base a n. So that's how we prove the exponent formula using the multiplication rule. So the next important rule is that if you take log base a, it's going to be equal to 1, because if the base and the argument are same, it should be equal to 1. And there's a really interesting way to prove this. What you can do is so we want to put this into the exponent form, and if we remember how to, it's basically going to be a is equal to a to the power 1, right? And this proves, because we move the base to the exponent and we keep the argument where it is, and that 1 becomes the exponent. So it becomes like the power. So a equal to a to the power 1, and this proves that log base a of a is equal to 1. So now that I showed you how to find log a of a, try and see if you can find this important property of a logarithm. If you have log base a of 1, what would it be equal to? Pause the video and try and figure it out. So what you would do here is you'd put this into exponent form, so the argument stays where it is. Oh, oopsie, the hand again. The argument stays where it is, and then you move the base to the base of the exponent, and we basically have a value. We'll call it n. So let's say n is the value of what we're trying to find. So 1 equal to a to the power n. And so for any other value than when a equal to 1 or 0, n has to be equal to, or for any other value when a isn't 0 or 1, has to be equal to 0. And so that means that this is going to be equal to 0. And that's another really important rule for the properties of logarithm. The last rule for logarithms is that when you have log base a of n, it's going to be undefined when n is smaller than or equal to 0. So n can't be negative. So like the argument of a logarithm can't be negative, nor can it be 0. Now there is one more really important rule called the change of base rule, but I'm going to cover that in a different video. So now try this problem without using a calculator, and if you get log base 10(6), you can keep it as is. You don't have to like try and figure out the value. It's really hard to figure out the value without a calculator. So pause the video and try and figure out how to do it. So the first thing we can see here is that we have base 10, right? And we have 600. And so we could split 600 into log base 10 of 6 times 100. And you may be asking why we should do this, but it's because if we split into 6 and 100, what is 100? What is log base 10 of 100? It's going to be like, we can put 100 in terms of 10 as 10 squared, and we can use some rules to further simplify that down. So since 100 is an exponent of 10, it's very helpful right now to put it into that form. So we can use our multiplication rule to say that log base 10 6 plus log base 10 100, and log base 10 6, we have to use a calculator to do it. It's really difficult to do it without a calculator, so we can just keep that like that. And then, but what we can do here is log base 10 100 is really easy to do without a calculator, so you can do plus log base 10 and then 10 squared. And so this is going to be equal to log base 10 6 plus, here we can use the exponent rule, so it's going to be 2 times log base 10 of 10. And this is going to be equal to log base 10 of 6 plus 2 times, and if you remember, log base a of a is always going to be equal to 1, so that's so log base 10 of 10 is going to be equal to 1. So the final answer is 2 plus log base 10 6. Good job if you got this. So in this problem, try and simplify log base a of x to the power n divided by y. Note that the to the power n only is affecting the x over here. Pause the video and try and do it yourself. So what I would first do here is try and separate this using the division rule. So it's gonna, oh, that happened again. So you want to do log base a of x to the power n minus log base a of y. And what you're going to do from here is we can use the exponent rule here. So n times log base a of x minus log base a of y. And after looking at the entire thing really quickly, you might think that you can't simplify this anymore, and that's correct. Like, there's nothing else we can do here. No more properties we can apply that will really help our situation. So this is the most simplified answer. Good job if you got this right. That's the end of today's video. Good luck.